Okay, we want to solve this problem today on equilibrium. We are taking our question from Utme, that's JAMB question 2000, year 2000. Okay, now the question we have here reads thus: a handbag containing some load weighing 162 Newton is carried by two students, each holding the handle of the bag next to him. If each handle is pulled 60 degrees to the vertical, find the force on each student hand. Yeah, this problem requires a sketch. Okay, now let's see how to do that. We have a handbag with a weight of 162 Newton. Of course, you know that a handbag, it has a weight that acts vertically downward. That's 162 Newton, that's the weight. Then there's a force from the arm here. There's another force from the arm here. Okay, and we have that each of the two forces is 60 degrees to the vertical. So that means when we have here, this is 60 degrees. We have this place, is also what? 60 degrees. Okay, now this problem can be easily solved either by force triangle or using Lamy's theorem. Now, how do we do that? If this place is 60, we can bring our stuff here. This is 60, this place will be 60. This is 60, this place also will be what? 60. And then this is 60, this is going to be 150. Sorry, 180 minus 60, that's 120. And this place as well will be what? 120. Now, from Lamy's theorem, this one is T1 and this one is T2, that's the tension. We know because they have the same angle and they are subject to the same weight, T1 of course is going to be equal to T2. So what we have to find is what? Either T1 or T2. Now we know that T1 over sine 120 is equal to 162 all over what? 162 over sine 120 degree. Okay? Because this is 120. So that is what we are going to calculate now. Now, as a sound student of mathematics, we know that this can easily cancel this. So T1 is what? T1 is equal to 162 Newton. So that means T1 is, we see T1 is equal to T2. So that means T2 also is equal to what? 162 Newton. That's from Lamy's theorem. Okay, the idea of Lamy's theorem is that when we have three forces, they must be concurrent, acting at a single point. This is the point. This one is T1, this one is T2, and this one is, let me use F rather. This one is F1, this one is F2, and this one is F3. This one is angle theta, this one is angle, let me use alpha, beta, and, this is alpha, beta, and gamma. So we have these three forces acting at a point. What does Lamy say about this? Lamy states that if we pick one force, like F3 now, then we divide it by the sine of the angle between the remaining two forces. These two forces now, the angle between them is alpha. Divided by sine alpha, then it will be equal to, or pick another force like F1 now, then we'll divide it by what? Sine of the, once you have picked F1, we are left with what? F2 and F3. So we find the sine of the angle between F2 and F3. That's what? Sine gamma. Right. Similarly, we can see F1 over sine gamma be equal to, let's pick F2 over what? Equals to F2 over what? Since we pick F2 here, we are left with F1 and F3. So we check the angle between F1 and F3. That's what the angle between F1 and F3 is better. So that means F1 over sine gamma is equal to F2 over beta. So that is Lamy's theorem that we have successfully used in solving the problem. Similarly, we can use just triangle of forces to solve the same problem. We have an handbag which has a weight acting downward. Okay, there's a weight 162. Then we have, to draw that you need to understand that we have an handle this way, we have an handle this way, then we have another handle, the weight here. So this is the weight of the bag, this is an handle, this is an handle. So we have T1 and T2 here. Alright, so we have to change it to a closed triangle. How do we achieve that? Very simple. Let's extend this one forward. So we have it this way. So this is the weight, alright? And this is what? This is T2. So this one can be closed. Right, so we have a closed triangle now. Now we know that the weight is 162. 162. Right. The angle between each of these forces and the vertical is what? Is 60 degrees. So this is 60, and this one too is what? 60. Automatically this one too will be what? 60. So this is what? An equilateral triangle. If the angles are equal, the side must be equal. That means this one will be 162, and this one will be what? 162. So T1 is what? 162 Newton, and T2 is what? 162 Newton. So that's the solution to the equilibrium problem that we had in the year 2000. Yeah, I will continue. I will solve as many questions as possible on equilibrium in the other years, and I welcome you to my blog. Please take your time to go through my work piece that I have. I've worked on ebooks and videos just to help students that are preparing for exams, particularly Utme. So I advise you to please once again go over this video until you are able to gain and to understand the concepts that I've highlighted and outlined therein. Thank you. I congratulate you for going extra mile in your quest for success. I wish you all the best.